Hey guys, hope you're doing fine. Welcome to another episode of CNC Talks. My name is Aman and in this video we're gonna learn how to create a basic CNC turning program for this component. So watch this video till the very end and let's roll. First of all, let's understand what is a program. So a program is basically a set of blocks. As you can see, there are certain number of blocks which are joined together to create a program. Each block consists number of lines, as you can see, and each line contains number of units. So for example, in this line there is G28, U0 and W0. Each code has its own specific purpose. For example, G28 is used to call the machine to its home position. So similarly, every other code, G96, G0, G01, every other code has its own specific function. Every code consists of two terms. First is an alphabet followed by a number. So in this case, G defines the geometric codes and 28 is just a number. In this case, G28 is a complete code which is used to move a machine to its home position. So at the end, we can say that a program is a set of blocks and a block contains number of lines, each line contains number of units and each unit contains a code which may be a G or M code or any other annotation. So the term N is used to denote a line number or a whole block number. As you can see, this N1 denotes the whole block while this N2, 3 and 4 denotes a specific line. Let's suppose there is a cylindrical component and we need certain kind of operation on it. For example, drilling or grooving. So we can create two blocks for each of drilling and the grooving, and for further, if we need to make any kind of changes in drilling or grooving, we can easily search them by the line number or the block number and easily make our changes. The term T denotes the tool number. Let's suppose this is a tool turret and there are 4 positions where we can mount our tool. So for example, let's suppose at 1 there is a grooving tool or at 2 there is a turning tool. So to call our tool at position 1, we can easily type T01 or T02 to call our tool which is at position 2. The term F defines the feed rate. For example, if we need to move our tool from one position to another with a given feed rate, we can easily type F with the feed. For example, if we wish to move our tool from A to B, we can easily type F with feed 0.2. That is how we can move our tool from one position to another with a given feed rate. Every program has its own name in the form of a number. For example, this O0000 is a program number where O is constant and the last 4 digits we can choose by our choice. For example, to name any kind of program, we can easily name O1234 or O2244. It only depends on us. EOB generally define the end of block. As you can see, each line ends with a specific sign. In cases of Fano control system, this sign is used as the end of block, and in case of Siemens, this sign is used as an end of block. Whenever a program is run, our machine read each line separately. For example, in this case, our machine firstly reads the line 1, execute it and then move to the line N2. And if we do not use the end of block, both the line will be termed as a single line and will be executed altogether. That is why we need to use end of block so that each line can be moved separately. So before we jump to an actual program, there are certain things we need to keep in mind. The first thing is the offset. Since you all know, to create a program we need at least 1 0 point from where we can take references. So in turning program, this point is generally considered as an offset point, or we can say the 0 point. So let us suppose this is our O point with coordinates 0, 0. So whenever our tool moves in all around the program, this point is considered as an origin and every other dimension will be considered from this point. Another thing that we need to keep in mind is the distance along x-axis. Since we all know that this is our x-axis and this is our z-axis. Suppose our tool is at position O and we need to move our tool from a position O to position A. As you can see, the distance between O and A is 5 mm since the diameter is 10, but in CNC turning we only give the dimension of the diameter. So to move from point O to point A, we do not give the dimension of 5 mm, but we will only give the dimension of the diameter, which is 10 mm. So let's generate the tool path for this component. So as you can see, our tool is initially at home position A and position E is the point from where the cutting will start. So first of all, we are gonna move our tool from point A to anywhere near the machine rapidly, which means the maximum possible speed. So as you can see, point A is the initial position of our tool and point E is the point from where the cutting will start. So in between the point A and point E, there are 3 stops. These stops are generally given for safety purposes. So what's gonna happen is our tool is gonna move from position A to position E rapidly, and then the cutting will start at position E, finishing the product and finally returning back to home position. So let's create a program for this component. So let's start with the program number. So let's suppose O1234 and end of block is our program number, and the first thing we need to do is to call our tool. So let's suppose T1 is our tool. So to call the tool we can type T101. Here T1 denotes the tool number while 01 denotes the offset number. Since it is extremely mandatory to take all the offsets before running a machine, so 01 denotes the offset number of tool 1. That is why 01 is always used while calling a tool. After that, we use G92. G92 is basically used to give our spindle speed a maximum limit. So in this case, G92S1500, it means our RPM will never gonna exceed from 1500. So in this case, our RPM is not gonna exceed from 1500. So in the next line, we use G96 with speed 150 and M03. G96 is also used for the cutting speed. So in this case, G96S150 denotes the cutting speed of 150, and also M03 is used to start a spindle in clockwise direction. Here we can also use M07 to turn the coolant on. So by using M07, the coolant will turn on at this point. Now what we need to do is to move our tool from home position to at point. Now we need to move our tool from home position to point E. So for that we are using G0. So we just need to give the coordinates with G0. So as you can see, point B, the x coordinate is 200 and the z coordinate is 10, which means the distance of point B from this point along z-axis is 10 and along x-axis is 200, considering the whole diameter. Now we need to move our tool from position E through all the positions to, let's suppose, to position T. So for that we use G01. In this case, G01 and the value of x and z for this point. As you can see, this point is 10 mm away along x-axis and also 10 mm away along z-axis. So that's why I gave the dimension xz and z minus 10. Further, from this point to this, there is an arc with a radius 5 mm, and also the arc is in clockwise direction. So for clockwise we use G02. So for that we can use G02 and the dimension along x and z axis for this point. So as you can see, this point is 20 mm, so x20, and along z axis from this point 10 and 10, this point is 20 mm away from our point O along z axis. So z minus 20, and also with the given feed rate which is 0.2. Also we need to give the radius value in this case. So at the end there are certain things we need to do. Since our spindle is rotating, so we need to stop it. For that we use M04, and also to stop the coolant we can use M09, and at the end M30 is used to end the program. So that is how we create a simple program for a turning. So that was all from my side today. If you find this video informative, give it a big thumbs up and don't forget to share with your friends. Also, if you are new to my channel, don't forget to subscribe. Thanks a lot.